In this example, we're going to look at how we can use Gaussian elimination when the system of equation is in the form of an augmented matrix. So first we'll write down the augmented matrix for this system of equations. Well, for that we have the coefficients and also what the equations are equal to. So we have 1, -1, 3, and 4. The next equation we have here is row we have 1, 2, -2, and 10. And for this equation we have 3, -1, 5, and 14. Just like that. Here's our augmented matrix, and the goal will be to have each row begin with its first non-zero entry to begin with a 1. And beneath each one we would like to have zeros. I think that the easiest thing to get rid of first will be this 1 right there. Let's try to turn that into a 0. To do that, we can just multiply the entire top row through by -1 and then add it to this row. Here's what it ends up looking like. So the first row can just be written down again because we're not planning on changing that, at least not right away. So we just write down that row once more. Now we're going to change this one, and the way we do it is we'll multiply the top by -1 and add it to this one. -1 times 1 is -1. -1 plus 1 is 0. That was what we wanted to do. -1 times -1 is 1. 1 plus 2 is 3. -1 times 3 is -3. -3 plus -2 is -5. -1 times 4 is -4. -4 plus 10 is 6. We can now just bring over the third row since that one was not involved. Alright, so we have this new matrix. It's equivalent in its solutions to the first. Let's try to get rid of this 3 and turn that into a 0. To do that, we'll multiply the top row by -3 and add it to the bottom one. I'm going to put the results over here. So the top row doesn't change, 1, -1, 3, and 4. The second row, again, will not change. So that remains 0, 3, -5, and 6. The bottom row we are going to change. How we will do it? Again, we'll multiply the top by -3 and add to the bottom. So -3 times 1 is -3. -3 plus 3 is 0. That's what we wanted to see. -3 times -1 is 3, and then 3 plus -1 is 2. -3 times 3 is -9. -9 plus 5 is -4. And -3 times 4 is -12. -12 plus 14 is 2. So far, so good. We've come a long way. We've got these zeros where we want them. I think it will help now if I see that every term, every entry in this row happens to be a multiple of 2. Let's divide through by 2. That has the advantage of making things simpler and also changing one of the entries into a 1, which is always desirable. So I'm going to just rewrite this augmented matrix so that that bottom row will divide through by 2. So we have 1, -1, 3, and 4. 0, 3, -5, and 6. Now I'm going to divide through by 2, so we get 0, 1, -2, and 1. So far, so good. In fact, this 0, 1, that's exactly what I would like to have in this middle row. And remember, it's always okay to interchange the position of two rows. That's one of the 3 things you're allowed to do in Gaussian elimination. So I'm going to just rewrite this whole thing, just interchanging those 2 rows. So here we have 1, -1, 3, and 4. Let me interchange the rows now. So 0, 1, -2, 1. So yeah, I wrote that third row in the second position. Now I'm going to put the second row in the third position. 0, 3, -5, and 6. So far, so good. It looks like all we need to do is, if I can just get rid of this 3, change that into a 0, we'll be in pretty good shape. To do that, let's multiply the second equation here now by -3 and then add it to this one. Do you see the advantage of having those 1s there? it allows us to just multiply by the negative of whatever we want to get rid of, right? Because if I want to get rid of the 3, I'll just multiply this by negative 3. Since there's a 0 there, it won't cause any trouble with this 0. All right, so here we have the top row. That doesn't change. 1, negative 1, 3, and 4. The middle row isn't going to change. 0, 1, negative 2, and 1. The bottom row will change since we're multiplying the second row by negative 3 and adding. So, negative 3 times 0 is 0, and 0 plus 0 is 0. Negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. That's what we intended to have happen. Negative 3 times negative 2 is 6, and 6 plus negative 5 is 1. Negative 3 times 1 is negative 3, and negative 3 plus 6 is 3. And here we have our augmented matrix in a triangular form. It has these zeros here, and the first entry that is not a 0 in each row is a 1. That's very nice because now we can use back substitution. You see, this term right here is telling us that the z must be equal to 3. In fact, let's rewrite this entire thing showing what the equation, the corresponding system of equations is. This top row is telling us that this is x minus y plus 3z is equal to 4. The second row is telling us that y minus 2z is equal to 1. The bottom row here, of course, is telling us that z is equal to 3. This is nice. This is in triangular form, which means that back substitution is quite simple. Let's do the back substitution. Since z is equal to 3, we can plug it in there, and we get y minus 2 times 3 is equal to 1. And that means that y minus 6 is equal to 1. Add 6 to both sides, and y equals 7. Now that we know z and we know y, we should be able to plug it in to get x using this equation. So we have x minus 7 plus 3 times 3 is equal to 4. This is telling us that x minus 7 plus 9 is equal to 4, which means that x plus 2 is equal to 4, which means that x is equal to 2. So now I have all 3 of the unknowns. We have our solution, 2, 7, and 3, x, y, z.